Bismillahirrahmanirrahim. Assalamu alaikum. This is Harulamia, and you all are welcome to the EDUqabill. And today lecture, I am going to start a very important chapter. This is disconnection approach. So, in this chapter, we are going to start about and to study about the retrosynthesis, synthon, chemically equivalent, and synthetic reagent, then functional group enter conversion, then one X disconnection, it means one group disconnection, then two group disconnection. So, in today's lecture, I am going to start about the general introduction of retrosynthesis and some order of event which are very important to understand about the retrosynthesis and disconnection approach. The retrosynthesis is the synthetic planning that start from the product and go back to reactant. So you see the best example in your screen that the red curve arrow which represent the breakdown of a bond. So this is our targeted molecule. This is our targeted molecule which represent by Tm. Tm is targeted molecule and the bond breaking occur between the carbon and oxygen. So therefore we write carbon X carbon and carbon bond over the disconnection arrow. This arrow is known as disconnection arrow, and when the disconnection occur they convert into the product. So this is not the product, this is called synthon, which one is bear positive charge and the other one is negative charge. This is called synthon. Now, this synthon will react with its opposite charge species and form a chemically equivalent compound. Synthon is an unstable species which form and disconnection which form and the retrosynthesis after the disconnection of a compound. Now we are going to discuss about the important rule for disconnection. This rule is very important for the disconnection and retrosynthesis. The first rule is that first recognize the functional group. It means that the functional group might be electron withdrawing or might be electron donating group. When the group is electron withdrawing group, they also impact the compound, and will they also when they are electron donating group, they also have some effect on the compound. So therefore we need to first recognize the functional group, where the functional group are electron withdrawing or electron donating group. The electron withdrawing group means that the functional group which withdraw electron from the compounds and make the compound electron deficient, while the electron donating group, it means that this type of group or this type of functional group which donates its electron to the compounds and make its electron rich. The next rule is that the compound containing two parts joining by heteroatom, so disconnection occur next to heteroatom, but remember that the disconnection next to aromatic compound like benzene is not the priority. It's why, because when the disconnection occur next to aromatic ring next to benzene and the positive charge occur on the benzene, we know that benzene is sp2 hybridized compound, and uh, we know that the positive charge on the sp2 hybridized orbital is unstable due to its because we know that, remember that point, that the electronegativity of sp hybridized compound is more than sp2. sp2 is more than sp3. So when the positive charge occur in the sp or in the sp compound, they are unstable. But when the positive charge occur on the sp2 hybridized, they are also unstable but less unstable than the sp. When the positive charge occur on the sp3 hybridized, they will be stable than the sp2 and sp. So when the positive charge occur in the sp, they will be unstable then sp2, and sp2 will be unstable then sp3. Okay, so Therefore, when the disconnection occur next to aromatic ring, so the positive charge occur on the benzene ring, and we know that benzene is sp2 hybridized, so the positive charge on the aromatic ring is unstable. Therefore, disconnection next to aromatic ring is not go to priority. Consider the following example. And this example, the disconnection occur in two positions, position A and position B. If the disconnection occur in position A, then the positive charge occur in the aromatic ring and negative charge occur in the oxygen, and synthon is formed. But we already discussed that the positive charge on the aromatic compound is unstable, so disconnection next to aromatic compound is not good to priority. In this condition, remember that disconnection cannot occur at position A. I explained the reason why, but in this position, at that compound, the disconnection occur in position B. If the disconnection occur in position E, no primary carbocation is formed and oxonium ion is formed. These two compound, which is called synthon is formed. Now these synthons are connected with their opposite charged species. When is the positive, the negative synthon will react with the positive species, and the positive synthon will react with the negative species and form as its chemical equivalence compounds. At this reaction, we derived the carbon oxygen disconnection over the disconnection arrow. So this example is very best to explain why the positive charge are unstable on the aromatic compound and why the disconnection cannot occur next to aromatic ring. Rule number 3 is that the disconnection occur at reactive group first. What means by the reactive group? You can see the compound in your screen. This compound contains three functional groups. One is amino, the other one is carbonyl, and the third one is ether. But remember here, the carbonyl is a terminal group in this compound. So disconnection cannot occur in the terminal group. Terminal group cannot disconnect it. Remember this, okay? So, and this compound, the one functional group is amine and the other is oxygen. We know that the reactive group is as that group which donate its electron pair easily. We know that the oxygen is more electronegative than nitrogen. So in this case, the reactive group is nitrogen. Because they are less electronegative than oxygen, they can donate its electron easily. Therefore, the disconnection occur at the carbon in fusion and form the synthons.